There's some interesting rational equations that we can solve in the form of a story problem. Some are called work-related problems. You know, maybe a contractor would use something like this when they have various employees working for them where those employees don't work at the same rate. Now, you know, they don't. They know how to do a good estimate of what the total time would be on the job with their various employees, but this would be a way to do it, seriously. So Zoe can rake her yard in 4 hours. Stephanie can do the same job, same project in 3 hours. How long would it take the two of them working together to rake the yard? So before we do this problem, I want to give you a feel for an estimate as to how long it would take. So let's say that they work for 1 hour together. Then wouldn't it be true that Zoe would get 1/4 of the project done in an hour, given that it takes her 4 hours to do the whole piece? And I'm going to put here Steph. She can do the whole project in 3 hours, so wouldn't she get 1/3 of the project done in that 1 hour? And so if I added the amount of the project that they would complete, the common denominator is 12 for these two. So, you know, I'd multiply this by a 3. That's supposed to be a 3. So Zoe would do 3/12 and Steph would do 4/12, and they'd get 7/12 of the project done, more than half. So that means in 2 hours they're going to be overdone with the project, because Zoe would get 2 out of 4 parts of that project done. Stephanie would get 2 out of 3 portions of that project. She got 1/3 done in an hour, she'd get 2/3 done in 1/4, she'd get 2/4 done. And so that would be 6/12 plus 8/12 for a total of 14/12. Well, they don't need to get 14/12 of the project done, right? They just need to get the whole project done. One whole project done. And so I'd like you to look at these fractions, and I'd like you to see that in my first estimate, I put the time they worked together, which was 1 hour, and divided it by the time they worked alone, which was 4 hours for Zoe or 3 hours for Stephanie. So I'm going to put here time together divided by their time working alone. And then I added Stephanie's portion, time together, over Stephanie's time alone, which was, I think, 3 hours. And I didn't want to get 7/12 or 4/12 of the project done. I wanted to get the whole project done. So this says, how long would it take the two of them working together? Do you see this time together here? That time together? That's my unknown. So what I'm going to do is I'm going to write in this thought right here, their time together is T divided by 4 would be Zoe. That's the portion of the project she'd do. 1/4, 2/4. You know, I need to find out T. Stephanie would be T out of 3. And they've got to get the whole project done. And I have a rational equation now to solve. I know my answer is between 1 hour and 2 hours. My least common denominator for this is a 12. So I'll multiply this by a 12, this by a 12, and this by a 12. 12t over 4 is 3t. 12t over 3 is 4t. And 1 times 12 is 12. And so finally, 7t on the left, and I'll divide both sides by 7, and it takes them 12/7 of an hour, or 1 5/7 of an hour. That kind of makes sense. You know, we thought it was between 1 hour and 2 hours because they got too much done in the 2 hours. Let's do this again with Bobby and Brenda. How long would it take if Bobby and Brenda worked together? So that's the numerator. Bobby is 20 minutes, so T over 20. Brenda is 25 minutes, so T over 25. And these fractions represent the portion that they each can complete, but they've got to get the whole project done. It's almost as easy in this problem to call the least common denominator 20 times 25. However, I will tell you that the common multiple that these both go into is the number 100. So let's go ahead and do that. Let's use 100. So let's multiply everything by 100. And so right here, 100t divided by 20 is 5t. 100t divided by 25 is 4t, and 1 times 100 is 100. The left side totals to be 9t, and when you divide both sides by 9, you get t is equal to 100 over 9, which in this case, let's see, 9 goes into 100 11 times. That's 99, and you got 1 left over. So 11 and 1/9 hours. Could I just talk to you about this answer and go back to Bobby, who can do this project in 20 minutes? So what if you didn't use Brenda, but you used a clone of Bobby, who could do it in 20 minutes? So if they're working together, couldn't they do that in 10 minutes? Wouldn't that be the time for 2 people that worked at 20 minutes each? But okay, let's say we can't clone Bobby, we can clone Brenda, and Brenda can do the project in 25 minutes, and we have another person who does it in 25 minutes. So half the time would be 12.5 minutes, half of 25. Your answer should always be between half of the small one and half of the large one, and 11 and 1/9 is in between 10 and 12 and 11. Just don't expect it to be right in the middle. And whatever you do, don't let me forget to show you a video of a movie that has this problem in it. That's a great baseball movie next time we get together. All right, let's finish up a couple more problems. These are distance, rate, time problems. And I want to write a formula over here. Distance equals rate times time, and remind you of this. Let's say you traveled with your car, because it's the easiest for us to understand, at a speed of 70 miles per hour. And you drove for 4 hours. That was your time. The word hours would cancel out, and 70 times 4 would be 280 miles. That would be your distance that you traveled. In these problems where we want to find the speed of the people that are walking, and we talk about time and we talk about distance, what we're going to do is we're going to set up a kind of a grid with this distance, rate, time idea. And in that grid, I'm going to set up 3 rows and 3 columns. And in those columns, I'm going to have a letter D, and then a letter R, and a letter T. Distance equals rate times time. And I'm going to go back here and read this and fill in some data. So let's see. Rosie walks 2 miles per hour slower than Sam. And I do want to find the speed, the rate. When we compare Rosie to being 2 miles per hour slower than Sam, then what we should do is let Sam have a rate of X. And let's create a row for Rosie, and she's slower by 2. So let's take away 2 from X for her speed. So we got to write a row for each of them. In the time it takes Sam to walk 8 miles, Sam, distance, 8. Rosie walks 5. 5, distance. In the time. This means in the same time. Sam can walk 8 miles when Rosie can walk 6 because Rosie is slower. Now, what I want to do is I want to take this formula, distance equals rate times time. You see this time column? All they told us is that the time is the same. I'm going to solve this formula for t by dividing both sides by r. That's, solving for the indicated letter. And time can always be found by taking your distance and dividing by your speed. So see this distance, 8, and this speed, x? I'm going to write Sam's time as 8 divided by x, distance divided by rate. And I'm going to let Rosie's be 5 divided by x minus 2. Distance divided by rate. And it says that these expressions for time should be the same because it can be done in the same time. Remember, x is Sam's speed. So I'm going to come way over here, and I'm going to set those 2 fractions equal to one another. I'm going to set the 8 over x, which is the time for Sam, to be equal 5 over x minus 2, which is the time for Rosie. And then I'm going to set these cross products equal. So I have 8 times the x minus 2 on the upper left, lower right. And then I have 5 times x. And then I'm going to distribute this. So 8x minus 16 equals 5x. I'm going to subtract 8x from both sides because I have the 5x on the right. And I want to keep this constant alone over here. And now I'll divide both sides by a negative 3. And I'll find out that x equals 16 over 3, which is 5 1/3. Now, see how Rosie walks for 2 miles per hour slower? If x is 5 1/3, that must be the miles per hour that Sam can walk at. So I'm going to put here Sam. Rosie is 2 miles per hour slower, so I'm going to take away 2 from that, and Rosie is going to walk at a rate of 3 1/3 miles. Now, to check this, what we might do is we could take, it's the same time, we could take this 8 divided by 5 1/3 and the 5 and divide it by 3 1/3 and see if the time turns out to be the same. All right, let's set one more up. An A train and an E train, and I'm not sure that I'll totally finish this problem. So same scenario. So distance equals rate times time. And then we have an A train, excuse me, and an E train. And the A train goes 12 miles per hour slower than the E train. Again, we want to find the speed of each train, so we want to put x's here. We compare the A train to the E train, that means we put the x here. Because the A goes 12 miles per hour slower than that one, so x minus 12. The A train travels 230 miles in the same time that the E train goes 290. 230, 290, same time again. So over here a fraction, 230 divided by x minus 12, 290 divided by x, because these are the distances divided by the rates. And when you set the 230 divided by x minus 12 equal to the 290 divided by x and set their cross products equal, so you have 230 times x equals 290 times x minus 12. I'm just going to look here and check this. It looks to me like x you will solve and find out that x is 58 miles per hour. That is for the E train. And remember that the A train goes 12 miles per hour slower, so when I subtract 12 from this, I'll get 46 miles per hour for the A train. And again, I can check it in this statement, 230 divided by, put in the value for x of 58, put in the value for x of 58. See if their times turn out to be the same. We have finished our work with simplifying, multiplying, dividing, adding and subtracting rational expressions, and solving rational equations by using our skills of factoring. And we're ready to go ahead and take our test over this unit.